You know what caught my attention last month? Well, NordVPN announced they're starting to use post-quantum encryption in preparation for the quantum computing era. And there's a big reason why. In this video, I want to break down what quantum computing actually is and why it's got security experts worried about our current encryption methods. And most importantly, what we're doing about it. Before we jump into all this, if you're new around here, let me quickly tell you what we do. Okay, we've spent I think over a decade reviewing security and privacy services. Our aim is to always stay ahead of the curve when it comes to sharing how leading organizations are upholding the privacy of your data and online activities. So if you want to stay in the loop on everything security related, and trust me, with everything that's happening right now, you definitely do. Go ahead and hit that subscribe button and turn on notifications. All right, let's break this down step by step. I'm going to start with the encryption we use today and its purpose. Look, the entire internet security relies on encryption. Basically, a way to scramble information so only the right people can read it. The encryption type we use everywhere is called public key encryption, and it works because standard computers are really bad at one specific thing: factoring really big numbers. Okay, like really bad at it. Your regular computer would need thousands of years to crack today's encryption codes. And this is exactly why us experts are worried about the potential security threats of quantum computers. Okay, because they could crack encryption data in a matter of minutes. See, quantum computers don't work like our regular computers at all. Your regular computer processes information in bits, either 1 or 0. Like a light switch that's either on or off. But quantum computers, they use something called qubits, which can be both 1 and 0 at the same time. This is called superposition, or a combination of multiple possible states. Think of it this way. If a regular computer is like flipping coins that can only land on heads or tails, a quantum computer is like having coins that can spin forever, being both heads and tails simultaneously. It's because of this phenomenon that quantum computers can crack encryption codes far quicker than today's current systems. Which, and I'm not trying to fearmonger here, but it's why traditional security can be dead in the water. The consequences could be, catastrophic. I mean, banks, healthcare systems, and all the cloud storage apps you use, they all rely on the fact that normal computers and the humans behind them don't have the lifespan to crack encryption codes. To call quantum computing a security emergency is quite an understatement. And this isn't just theoretical anymore. Okay, companies like IonQ are already building these quantum computing machines. And we're talking about some serious sci-fi level tech that's happening right now in labs across the world. Okay, big names are in the quantum game too. Amazon is developing its own quantum chip, and Google just announced a quantum chip called Willow, which insiders are describing as mind-boggling. Google claims its quantum chip could solve ultra-complex problems in just a matter of minutes. For current computers, the same problems would take 10 septillion, yep, you heard that right, septillion years to solve. And that's longer than the age of the universe, by the way. And why is all this happening? Well, despite the security risks, quantum computing can hugely benefit society. It has the potential to speed up scientific research and drug discoveries for healthcare and improve everyday services, like search algorithms. All things considered, quantum computing has the ability to change the world and make our lives better. But right now, we can't ignore the security risks, especially once quantum computers get into the hands of cyber criminals. If we don't react to them, they could cause an absolute mess, like breaking TLS encryption and authentication systems, just like that. So, what's the solution? Well, it's post-quantum encryption. Okay, let me explain what post-quantum encryption is so you know how it works. I know this is all pretty complex stuff, but I'm gonna do my best to simplify it for you. So, the goal is to create more complex mathematical structures way more complex than we have now, to make it harder for hackers using quantum computers to break through encryption protocols. And right now, experts have developed several types of quantum-resistant encryption. The most promising one, as in the one that would best protect our data the most, is called lattice-based cryptography. It's a collection of vectors within a grid which creates a maze-like system. To break through this type of encryption, a computer would need to answer questions like, which is the shortest vector in a lattice? Or which vector is closest to a specific vector of interest? As simple as these questions sound, they are actually difficult to answer, let me tell you. It's beyond human possibility. Standard computing, and even as experts say, beyond the possibilities of quantum computing. Then we have hash-based methods. This is also extremely complex, so let's use an analogy. Think of the hash function like a magic blender. Okay, you can put in some ingredients, or in the real world, a message or numbers, into this blender, and it turns them into a totally mixed up smoothie, otherwise known as a hash. And every ingredient then makes a unique smoothie, and you can't figure out the original ingredients just by looking at that smoothie. Even with a quantum computer, figuring out the secret ingredients from that smoothie is nearly impossible. Why? Because the blender scrambles the ingredients in a super random way. Sure, quantum computers are fast, but hash-based methods are designed to confuse them and make it impossible for them to break down the encryption process. And companies are already jumping on board these quantum-based encryption methods actually. NordVPN just announced they're implementing post-quantum encryption in their Linux app. Google's been testing it. IBM's been working on it. This is happening now. Since 2021, email service Proton Mail has been working on ways to secure your emails in the quantum computing era. It's gone down the lattice-based cryptography route to not just keep emails between Proton users secure, but also emails sent to others and from other providers. So, while hackers are certainly a threat in the quantum era, it is refreshing to see companies are aiming to stay ahead of the game to keep user data safe. And this isn't just companies doing their own thing. In August, and this is huge news, the National Institute of Standards and Technology finalized 3 new encryption standards specifically designed to resist quantum computers. I mean, let me back up a second. When NIST does something like this, it's a big deal. Okay, these are the folks who basically set the standards for encryption that everyone uses. They're basically saying, this is coming and we need to be ready. Now, what exactly are these new standards? NIST has released 3 main ones. First, there's MLKEM, which is for general encryption. This makes it easy for 2 parties to exchange information in a fast and secure way. Then there's MLDSA, which protects digital signatures and ensures there's no unauthorized modification to user data. It also authenticates the identity of the authorized signatory. And finally, number 3, there's SLH-DSA, as a backup for digital signatures using something called Sphinx Plus. Sphinx Plus is a hash-based signature scheme that will be the standard for NIST post-quantum cryptography standardization process. It's quite a mouthful. Now, I know these names sound like something out of a sci-fi movie, or even names Elon Musk might consider for his kids. But they're all based on math problems that even quantum computers would have trouble solving. It's like, you know how kernel encryption is a really complex combination lock? Well, these new standards are like having a lock that uses a completely different mechanism that nobody knows how to crack. But, and there's always a but, these new protocols are not without their downsides. See, these new security measures are a lot more demanding. More space, more computing power, the works. And that's exactly what NordVPN found out. When they started testing their post-quantum encryption, they noted slower connection speeds and slower all-round performance, noting this mainly being down to larger and more complex encryption keys. And the timing of these latest encryption standards is no accident, because what really concerns the cybersecurity community, we're already seeing cyber criminals collecting encrypted data. They're calling it harvest now, decrypt later, or retrospective decryption. Cyber criminals are basically betting they'll be able to crack it once quantum computers are powerful enough for them to do so. Think about that for a second. Everything you're encrypting today, your emails, your banking information, your private messages, could potentially be stored somewhere, waiting to be decrypted in the future when quantum computers are powerful enough, which many experts believe could be within the next 20 years. So, what can you do right now? Look, as someone who's been in cybersecurity for years, I recommend that you, one, start looking at services that are implementing post-quantum encryption. Now's the time to start. Consider using services that combine traditional and post-quantum encryption for extra security, like Proton. You should also be mindful of what sensitive data you're encrypting. Remember that harvest now, decrypt later threat? We're not in immediate danger. Today's quantum computers have only a few hundred qubits, and we'd need, get this, at least 1 billion qubits to break today's encryption. That's quite a gap to bridge. And the good news is the cybersecurity community isn't sitting idle. Okay, NIST has been working on this since 2016, analyzing data, considering threats, and working on solutions. Plus, Cloudflare, one of the biggest networks on the internet, is also deploying a hybrid post-quantum encryption solution. I do feel there will be a positive conclusion to all of this. And remember, it's not all doom and gloom. Imagine a world where quantum computing could cure disease through advanced medical research or improve our quality of life thanks to, climate modeling. The same power that makes threatening to security also makes them incredibly valuable for solving some of our biggest challenges. What do you think about this quantum computing threat? Let me know in the comments below. And if you found this video helpful, smash that like button and subscribe for more tech security content. Thanks for watching, and I'll see you in the next one.